Hello everyone, welcome back to the Harness series. In previous videos, we focused on continuously integrations. In episode 1 to episode 5, we discussed on the harness basics and continuously integrations in production grade. In episode 5, we discussed on DevSecOps continuously integration using the harness and we run the pipeline and on AWS. Till now, in 5 episodes, we learned how to build the application, run the test cases, and create the Docker image and push the Docker image to the ECR and securities, Trivi, and we learn these concepts still now. Now it's time to take that CI pipeline and add CD and we deploy the application on the Kubernetes. And if you remember in episode 3, I used in the CI level in Docker Delegate agent. And today video also, I will deploy the two projects. First project is healthcare application and second project is I will use GoCart e-commerce application. In healthcare application, I will use Docker Delegate agent and GoCart application. I will use Kubernetes Delegate agents. I will deploy the application and we will access the applications. And what are the drawbacks in the Docker Delegate agents and why everyone using the Kubernetes Delegate agents and what is the features use there? Everything we will learn in today's video. By end of the day video, you will understood everything on the Docker Delegate agent and Kubernetes Delegate agent and how we can deploy the application using the harness in Kubernetes. Okay. And before I'm explaining the project and before going to the hands-on demo, you need to understand few concepts. I know everyone know the Kubernetes knowledge, but I need to explain. I will recall the concepts. Okay. And episode 1 to episode 5, build, test, and push the image. And episode 6 to episode 10, deploy the application on different delegate agents. Okay. In today's video, we are covering namespaces, Kubernetes namespaces. It's isolated namespaces, and using that namespace only, we are deploying the application, the GoCart applications, and config map and secrets. And the secrets we are storing the database details and deployment file and services and pods. I I hope everyone knows these concepts. Okay, and deployment strategies and some of peoples don't know the deployment strategies like rolling update, blue green, canary mode, and recreate. Don't worry, I will just recall the features. First, we will go for the rolling up rollout. See, suppose you deployed an application today, and after 1 week, you want to deploy a new version. Kubernetes does stop the old application immediately? No, right? Instead of Kubernetes performing rolling out, rollout. See, rollout is a replaced old pod to the new pod, and users, if accessing your application in version one, they will don't feel anything on downtime. This is minimalized uh, downtime, and it will provide very smooth deployment experience. And harness provide monitoring that rolling out and everything you will able to see on the harness UI dashboards. Okay, and we have to understood the health checks also. See, health checks, we deployed application and we are using the rolling out. I didn't mention the rolling out here concept, but don't worry, I will explain the rolling out. See, rolling out, you updated first version to the second version. I'll take the pen. First version is everyone is accessing, and second version you deployed and new pod to old pod it's done, and the second pod before rolling out deleting the old pods, it will verify the pods are running, our pods are healthy, and health checks. If everything is good only, it will be roll out and the second version will be access the peoples. If any issue came in health checks, automatically it will be rollback. This is the features. I will explain the rollback concepts and everything. And harness also monitor the deployment health checks and before your deployment going to the success. In entire pipeline only, we will able to see in today's video. Okay. And we have a many deployment strategies is there. Different type of applications is there and different type of requirements is there. But Kubernetes provide multiple deployment methods and harness cloud will support all deployment strategies. If you take example, rolling, blue green, canary modern, canary deployment, and recreate. Wait. Okay, these are all the features. Okay, now I will explain rolling concept. Please understood these concepts. If you know, just remember whatever I am explaining. If you don't know, please remember and take the notes because these four topics is very important. If you understood these four topics, you will understood entire pipeline, whatever I'm explaining this upcoming 5 videos. See, rolling deployment, this is the one of the most common deployment strategy. Instead of replacing the all pods at a time, Kubernetes will create new pod with updated version, and once updated version is healthy and it will remove the old pod. The entire process will be going on one by one, and this ensure the users will be doesn't experience with the downtime during these updations. I will give you one detail example. Suppose you deployed application version 1. You have a 4 pods. Okay, and you want to deploy the version 2, and this rolling deployment, first it will create one pod, and if this pod is the new version v2, and after deployment the health checks will be checked this pod is healthy or not, and this application in this pod application is running or not, whatever the health checks is there, everything it will check, and if everything is done, and it will delete one pod, and second one more pod it will create, same process here, healthy, and delete this pod, like that, one by one, everything here, health checks and everything, and delete the old pods, and users will be accessing on the version 2. This process entirely on one by one process. First pod will be create and second pod it will be create. And see the rolling and rollout. Rollout, rolling deployment and rollout are not exactly the same. Rolling, it is a deployment, rolling deployment, it is a deployment strategy. It is a deployment strategy. But rollout, it is a process to apply the deployment. Understood? The rolling is a deployment strategy to and rollout is a process to apply the deployment. And see the rolling, it's defined how to deploy the application and how to update the applications, and Kubernetes will be replaced one pod to the new pod. Gradually, it is going on one by one. And the rolling goal is zero downtime. And coming to the rollout, it is exactly how it will work. It is execute for the deployment commands. Suppose if you run Kubernetes kubectl apply minus f deployment.yaml file, the Kubernetes will start the rollout. And if the deployment strategy, it is a rolling deployment only. Using it is a default rolling deployment. Using the rolling deployment, it will roll out and it will deploy the new versions. And in the simple way, rolling is a deployment strategy, and rollout, it is a process to apply your deployment. I hope you understood this concept. And coming to the blue green and blue green application, we are using on the Docker Delegate agent project. It's a healthcare project we are using, and we are not using the blue green on the GoCart application. And okay, how it will work? Blue green. See, okay, first I will remove this all and I will take two different colors and I will explain. You will understood the blue green concept. Okay, first I will take the blue. Okay, this is the blue. Blue is a current version. Suppose V1 blue, and users will be accessing the blue. Blue represent it is a current version. Current version is V1. It's a blue. It is represented as a current version. And coming to the green, it is represent as a new version. New version is V2. Okay, users will be accessing the V1, and the green is the V2, and the V1 has a no problem. Health checks is passed. Users will be accessing the application and everything, and our developers will be created the version 2 and started working, and it send it to the DevOps team. And DevOps team want to deploy the application, but they don't want to use the rolling update. They want to use the rolling update with blue green deployment. And blue green deployment, if application is failed means they immediately want to switch to the V2. That's why first their V2 deploy application, they deploy the application. It is another container. This is one container and this is the another container. Both are different identical environments. And it will deploy the application, check the health checks. If everything is good, immediately it will switch to the V1 to the V2. And V1 it will be delete. And current application is V2. And users will be doesn't feel any downtime and this process. Suppose V1 application is users will be accessing, and V2, this is a different container, and users will be not accessing this container because we didn't deploy an application. We deployed only V1 application, and users will be continuing accessing the V2 applications. The testing team or DevOps team there will be deploy the application, and there are health checks. It is going at that time. The health checks is failed means there is no downtime. The application automatically it will delete it V2, and they will fix the issues, and again the V3 version will come or V2 version will come. If everything is passed, immediately swap the application V1 to V2. Just there will slap, and the green traffic immediately, whatever the green traffic, immediately it will come back to the blue. Understood? If green deployment is success, the blue traffic will come to green. And this green deployment only it's failed automatically. Whatever the traffic is there, it will automatically switch to the blue again. And during this process, there is a no downtime. Okay, this is the blue green application. And whenever I'm explaining the healthcare application, at that time you will be understood very clearly because hands-on demo is very understood while deployment. Okay, and next Canary deployment. Suppose V1 version. This is the one application. Users will be accessing this application, and developers are building the V2 version, and development is done and send that code to the DevOps team, and DevOps teams want to deploy the application. But here your client said, I want this feature. Suppose I will take one Flipkart application. This is the Flipkart application. uh, Users will be accessing the Flipkart application version 1, and this is the version 2 Flipkart application only. I have a 10 iPhones is there, 10 iPhones, but these iPhones I want to give on 80% discount. Just understood the concept. I want to give the this 10%, 10 iPhones 80% discount. Okay, but if I been entire if application 10 applications, 10 iPhones the users will be purchased immediately, this I want to delete that version. Okay, and this 10 application 10 iPhones product and 80% on return on the version 2. Okay, and I want to deploy the application, and I at the same time this application one also will be run execute. Okay, there is a total uh, many users is there, but we will take 100 users. Okay, the both applications is going on, and your client said the two version will be work, but version 1 will be more than 100 peoples, 90% will be use the version 1, only 10% peoples only use the version 2. At that time we will use the Canary model deployment strategy. V1 is equal to 90%, and we have to write the code. Okay, and V2 and only 10%. 90% means 900 90 members, and 10 means 10%. Okay, and we deployed the both applications on two different containers and full production grade applications and secured and everything. The users will be accessing the V1 and V2. Okay, now take we will take 100 users. First user will be hit this one, second user this hit, third user hit, fourth user hit, 5, 6, 7, 8, 9, and 10th user will hit on version 2. In this entire 10 requests, we don't know at what request will go to the V1, at what request will go to the V2. Out of 10, there is a one request, definitely it will go to the V2. Same like that, out of 100 requests, 10 requests will be go to the version 2. Even we don't know at what request, at what time it will go to the V2. We don't know, like 10 requests at the same time only we will go to the V2, and next 90 requests will be go to the V1. Once go to the request and user will be hit and buy the 10 iPhones, and the admin will be see the okay iPhone stock is done, and the client said delete the version 2, and they will delete the version 2, and Canary modern deployment they said the version 2 is deleted and shift to the 100%, and we can shift the 100%, and next 100 users will continuously hit on the version 1. This is the Canary deployment. I hope this is better understood. If you still didn't understood, don't worry. Tomorrow or day after tomorrow or episode 7 or 8, we will use this hands-on demo. But today's video, I am not using the Canary modern deployment. Okay. And this is the Canary one. And recreate. See, this is the very simplest deployment strategy. And to be frank, no one will be used. It will only use dev team or testing team only. But Canary modern deployment, it's a high traffic apps. High traffic apps means Amazon, Flipkart kind of applications, because they have very only limited products, and that limited products will be keep it, and if the product is done and they delete that versions and like that. And not only Flipkart and Amazon, there are multiple companies or multiple applications there are use Blinkits and what multiple Swiggy, Instamart, multiple they will use the Canadian modern deployments, and the traffic will be sent. Suppose we deploy, suppose we have a two AWS accounts is there, two Kubernetes clusters, or we deployed one account is one cluster, and the second cluster we deploy two applications. The one load balancer is there. First request will go here, second request will go here. Out of 100 requests, it will go 50 here, 50 here, like that. You don't know, like multiple ways we can use the Canary model deployment. Okay, and recreate. To be frank, it will be used only dev level only and testing level only. And blue green means like it's very critical apps only. And rolling is most common apps you will use. Every app, every application there will use, and it's a default. Rolling is a very default is a inbuilt features. And blue green, if you want you can use, or Canary if you want you can use. But recreate usually they will use on dev and testing. How it work means recreate first. Suppose if you have a five pods are running. Okay, and that is v1. Okay, now you want to deploy the v2 and recreate how it will run, right? First it will delete this all and it will recreate and new pods. And at that time we have a downtime is there, because we deleted the all pods and we created the new pods. At the time the downtime is there and the users will be not able to application. That's why this is only used on the uh, very developers are testing only. There's a local environments only they will use these features. And coming back, there's an important feature is rolling rollback. Okay, okay, these concepts I will explain while I am explaining at the code. See how to test the rollback. I will explain this entire concept later on, but just understood how it will roll back. So there is a two waves is there. One is manual rollback and automation rollback, and everyone will know we will use the automation rollback. See, you deployed application in between in the pipeline. There is a total five steps, 5 steps or 4 steps or 3 steps, any steps is there. And out of one step is failed or one stage is failed, automatically previous application will be uh, come and the users will be accessed. And if pipeline is break, the previous pipeline will execute and previous pods will be recreate and everything the users will be accessed. And this is the very common way, and this is the how it will work the rollback. And while I'm explaining the code at that time you will understood betterly. Okay, now coming back to the applications. Okay, this is the deployment applications. Total two topics I'm explaining in this video. Total two different applications I'm explaining. We have a two delegate agents. One is Kubernetes delegate agent, and second is Docker delegate agent. And if you remember on the episode 3, we used Docker delegate agent on CI level. Usually in the CI level, we will use on the only, harness cloud only. But at the time, I want to explain the Docker delegate agent in CI level only. That's why I explained you. At the time, I told no one will be use the Docker delegate agent on CI level. But I explained, because why I'm explaining means at that time I allowed the network host, I allowed the tag, and I run the Docker delegate agents at that time. But today's video, we are not allowing the network host, and we are not adding any tag names, and we are not running that Docker delegate agents. We are just installing the Docker delegate agents. Once it will install, it will connect the Docker delegate agent and it will run the Docker delegate agents. Okay. And the Docker delegate agents, first we will create one EC2 instance. In that EC2 instance, we will install the Docker and we will install the Docker delegate agents. And this Docker delegate agents will perform all tasks, whatever you run the pipeline. That is the first topic. Topic one is healthcare application deployment. And that healthcare applications are used HTML, CSS, and JavaScript, and backend Python. This is very small application. And second topic, it's a project two. We are going the GoCart e-commerce applications. Code is Node.js, and we are using the Docker delegate agent, and we are creating the Kubernetes cluster in the production grade, and we are using the EKS Auto Mode. I will explain how to create the EKS Auto Mode Kubernetes using the Terraform and GitHub actions, and everything the pipeline will run, and we will able to access the application on the load balancer. Okay, this is the concepts. And next, we have a few prerequisites is there. First one is GitHub connector. we already connected a GitHub connector in episode 1. If you're watching this first time in this video, I'm kindly recommending please watch my previous videos. After that only you have to come back and you can watch these videos, because some of the connectors, secrets and variables, whatever I created the previous episodes only, I'm using the same thing, because it's recreating one more time means who are watching this entire series, maybe there will be get some bore. That's why whatever I'm explaining, same thing I'm explaining this, maybe they will get the bore. That's why I'm not using that same, I'm using the previous ones only. Okay. I'm Docker delegate agent and Kubernetes delegate agent only. I'm two agents only I'm creating in this video. Remaining everything I am using the previous videos. Okay. And GitHub connectors we created on the episode 1. If you didn't watch, at least you have to click this one. You can go back and you can st- follow the steps and you can create it. And all end to end this project steps and everything I given the readme file. I will share you that this GitHub repository in the description, and you can fork and you can use. And AWS OpenID Connect we used on episode 3, and secrets and variables I am using the same. Actually, secrets and variables I am using only for the creating the repository. Usually we can create the repository manually, but I'm using the pipeline to create. That's why I'm using the AWS security and access key. And episode 10, at the time I will not use this AWS security and access key. At the time I will use on the pipeline only. GitHub Actions or Terraform code only I will use. At the time I will not use the AWS security and access key, because the episode 10 is the production grade deployment application. Whatever you learn episode 1 to episode 9, I will explain everything in the episode 10. Okay. And AWS account ID and region, I am using this entire whole series. I am using the US East 1 region. Is a Northern Virginia region I am using. Okay, these are the prerequisites. And let's go for hands-on demo. Okay, and first healthcare application. Okay, and first I will create one EC2 instance. I will install the Docker, and slowly we will be. I will explain the step by step. Okay, this is my instance. I'm creating the US East 1 region only. Okay, I need to sign in. Just 2 minutes, guys. I will sign in. I sign in my account. Okay, this is my AWS account. Okay, US East 1 region. Go to the EC2. Get start. Okay, and name. This is the tag name, but please remember this tag name, whatever you are giving, because in this, if you didn't add the tag name, means it's very difficult to identify the harness which EC2 instance we need to deploy the applications. For example, if you have a 10 EC2 instance at the same region, and at the same region you have used the different key pairs also, and in out of 10 EC2 instance you install only one Docker agent only, but harness will be not identify that Docker delegate agent in which EC2 instance you install or not. And if you install also, but it will not identify it, because there's a multiple EC2 instances there, and multiple EC2 instance it's running on the with same VPC only. That's why it's very difficult to identify. That's why you need to add the tag name in Docker delegate agent at the time. Okay, tag name is not Docker delegate agent. When you are running the pipeline at that time, you have to add the tag name in the services. I will show you when I'm setuping at the time. But here I'm using, you can use any name, but remember that name. I'm using the CD Docker delegate. Okay, I'm running the Docker delegate agent. That's why I'm choosing the T2 medium with 2 CPUs and 4 GB RAM. And you need to create one key pair. Using that key pair only, it will come and it will be run and execute. I'm using existing key pair. And VPC, I'm choosing the default. And security groups, I'm choosing the default security group, but we need to allow the SSH22 and port number 5000. In the 5000 only, we are deploying the application. Okay, and storage, I'm giving 30. Add IAM role. Just add IAM role, but whenever I'm explaining the code at the time, why you added the IAM role, I will explain. Using this IAM role only, you will able to deploy the application and everything. And this is the very complex Docker delegate agent while you are using, because that's why everyone using the Kubernetes delegate agent only. But Docker delegate agent in the local environment, like dev environment, testing environment, also I don't know there are companies are using or not, because this is a very latest tool, right? Even I don't know there are using or not. Even my organization, we are not using. We are migrated, but we are not using that in local, and still we are using the Jenkins and GitHub Actions only. But in the production only, in one environment only, we are using the harness only. But the Docker delegate agent, whatever I learned in my learning experience, but Docker delegate agent, it's very too complex to install, and we can deploy the applications. Okay, I will show you the everything, and just whatever things, just name. I added the T2 medium, key pair, and default network VPC and security group. I allowed just default. I will want to allow the port number 22 and 5000. My application is running on 5000. And storage I given 30, and I added the IAM role with administration access. I'm just saving. Launch instance. Okay. Now connect the instance. We can connect directly with the EC2 instance connect, or we can use directly SSH connect. I will use the SSH connect. Okay, and it's taking time. Okay, it's open. Okay, go to the Docker. Yeah. Go to the root user. Okay, root user. And here open the deployment steps. Don't worry, I given the every steps here. You can follow this one. And I think the better way you have to watch my video and take the how I am adding and everything. After, if you still stuck anywhere, you can use this referral deployment dot md file. Okay, run these commands. I'm installing the Docker, and I'm installing the AWS CLI. AWS CLI we need to install, because without the AWS CLI, the commands will be not execute on the Docker uh, delegate agent using the AWS EC2 instance. That's why we need to execute. Okay. Okay. And we need to add the security group. Okay, go to the securities. I already added the port number 22, and I already added the all ports. Okay. You don't add it means directly go to the default security groups and edit inbound rule and add it directly. Okay, edit inbound rule and add it directly. Okay, this is a port number 5000 and port number 22. The two ports you need to allow. Okay, it's done. And next, okay, it's done. And next, we will install the Docker delegate agent. Before installing the Docker agent, and we need to set up the AWS key pair, right? Okay, first we will install the Docker delegate agent. Okay, we'll go on step by step. And this is the harness. Still now we use the continuously integration, right? And now it's time to continuously delivering and GitOps and click get start. But both are same only. See, I created the harness CI/CD 0 to hero in continuously integration. Here also it is there. If you open and you will able to hear the new things here able to see it. And just open it. Just it will automatically open it. You just close this one. Okay, here and go to the project settings. whatever we created, everything it's already is there. Okay, I will delete this Kubernetes delegate agent. Go for secrets and variables. See, these all are things we created on the CA level, right? But same things here also is there. You don't need to create again in the CD also. Okay, go to the delegates. I will delete my Kubernetes delegate agent. Okay, and I still refresh. Okay, install a delegate agent. Choose the Docker. I will change the name and I will choose the same name only. Whatever I given the name, I will choose the same name only. See, when you are using my code, when you are practicing at the time, first whatever I added the tag names, secrets and variables, whatever the tag, secret names, everything, you have to choose same thing only. After once you successfully deployed my application, after that only you need to change the Docker delegate agent names, tag names, project names and everything. At the time you will understood what I'm explaining and what you are doing and everything. Once you deploy the application, you will get some confidence, and after that you can deploy the application with your own names. CD Docker delegate agent. Don't worry, I given all names in the README file. Yeah, CD Docker delegate agent. Okay, I'm just copying this one. Docker PS. Yeah, and next, these all things I explained on the episode 3 also. I'm just installing the Docker delegate agent. Okay, it is pulling the image. Okay, it's done. Again, if you run the Docker PS, see, this is the Docker delegate agent. Okay, and now I will be installed. Okay, done. Now just verify. Click verify. It automatically it will success. The delegate agent will be success. Usually it will be take 2 to 3 minutes to get activate. That's why we need to wait for 2 to 3 minutes. And when once you creating the EC2 instance, at the time the key pair it will automatically download, and that key pair it will be stored on the your download files. Okay, and it's done and it is connected. Okay, now go to the project settings. In this project settings, go to the secrets. Here, choose SSH credential. Here, choose EC2 as SSH key. Okay, and I already given here everything. Just if you choose this right name, okay, and continue and choose SSH key. And here we created the Docker delegate agent, right? And the EC2 user name also EC2 user only, right? We have to add the same thing only, EC2 user. And the secrets, we need to create one secret and choose here file. Okay, and create a new secret file. Just click the browser and select your key pair where are you it's downloaded. This is my key pair. Okay, I uploaded the key pair. Okay, and this key pair name EC2 pemp key. If you change the name also, there's no problem. Okay, and save it. This key automatically save and continue and finished. Okay, now we need to test this key pair is working or not. Go back, details, copy the public IP test con. If it is success, it is working. It is connected everything and finished. Okay, now we need to create the services. Usually, these services and environments, we can create automation scripts, but in this video, I will create manually. Not only this video, on episode 6, 7, 8, and 9, I will create manually. On episode 10 only, I will create automation because in every company, the services and environments, we will be create on automations. We will run the Terraform script, it automatically create. Using that script, we will write the pipeline and the pipeline will execute and everything it will create. But here I am creating the manually because you need to understand what the futures, what are the type of futures is there in the services and what futures I'm explaining. And if you understood these futures, you will able to understood in the upcoming videos and automation script also. See, if your uh, basics is strong, means in upcoming videos it's very easy because the fundamentals you have to learn today, and the services and environments I'm creating the manually because this is the fundamentals we have to learn. And after that only, if you understood the advanced concepts, means it's very easy. See, nowadays copying the code and running the code, it's everyone will do. Even the fifth class, sixth class student also will how to write the Python code, means they will write and ChatGPT will give the code and they will execute. Everyone will do. But the problem is you have to understood the code and you need to deploy the project. That is the main thing. If you understood the troubleshooting at that time, you will able to clearly fix that issues. You will easily identify the what is the issue and you can easily fix that issues. That's why. Okay, I'm creating a new service. We can import also, but I don't want to import because I didn't return the code. I'm just creating the service in the manually. Okay, and services, I will use the harness website because my application name is harness website. If you open the code, just open the duplicate. I will open the pipeline. According to my pipeline, I will create the service and everything. Go to the harness, sorry, healthcare. Go to the harness, and this is the pipeline from the Docker. Don't worry, I will, before running this pipeline only, I will explain the code and everything. Okay, this is my harness um, name, harness cloud SH key for the service name, healthcare website. This is the name. I'm copying the name. I'm adding this name. The same name only, the ID also. This ID, it will identify whenever I run the pipeline, this ID will be identified and it will execute. And I'm choosing the inline save. It's created. And now I'm using the shell script. Okay, and save directly. Wait, save option here. Okay, I created the services. If you go back now, this is the service. Okay, if whenever you run the pipeline, at that time you will able to see the deployment status and timeline when the application is deployed and services fails and filters environments, everything you will able to see it here. Okay, and now time to create the environments. Okay, and create environment. I will choose my environment name is deployment. Copy this deployment. Okay, I'm choosing the pre-production and inline save. Now we need to create the infrastructure. See, this infrastructure, we created the Docker delegate agent. We created the, this is the EC2 instance. In this EC2 instance, we created the Docker delegate agent. Okay, and this is the harness platform. In this harness platform, this is the pipeline. Okay, and this pipeline want to execute to the Docker delegate agent, means in this Docker delegate agent will be help. And using the Docker delegate agent only, we need to add the infrastructure. The responses will come back, right? And this Docker delegate agents, using this infrastructure, whatever we created here, the Docker delegate agent, this Docker delegate agent, the infrastructure, we need to add it here, platform also, right? Now we are adding that infrastructure platform. Okay. Okay. I don't remove, I will keep it, and I need to explain again. Okay, go to the infrastructures, create an infrastructure. Okay, my infrastructure name EC2 Docker. EC2 Docker. Okay, my ID also EC2 Docker. I'm choosing the inline. Okay, my deployment type is shell. I'm choosing the shell. Okay, and I'm choosing my AWS because my in the AWS only my EC2 instance is there, right? It will take that EC2 instance and it will deploy it. And now connector, my AWS connector. This is the OIDC, OpenID Connect, and region US East one. My EC2 instance is US East one. This is the my key pair we already tested, and the public IP only we using the public IP, and the this is the VPC 5B. It's automatically it's fetched the VPC. Yeah, E5B, E5B, and here we need to add the tag name. If we didn't add the tag name, see here we have two EC2 instances there, but it will not identify which EC2 instance I want to deploy or which EC2 instance is the Docker delegate agent is installed or not. It will confused and it will not deploy any application. That's why it will automatically fail the pipeline. That's why we need to add the tag name. If we add the tag name, automatically it will be identify that EC2 instance and it will be installed. The pipeline will execute and it will install the project and it will we will able to access the application in a simple way. The CD Docker delegate agent. I will check 1 second, cross check because it's very important. Yeah, CD Docker delegate agent. I'll copy this one because check the spaces is there or not. If because if this name is wrong, the pipeline will be failed. Okay, and we added the SSH keys and everything, and just save it. The infrastructure also it's created. Now the pipeline is created, and this suppose we in the pipeline we added the infrastructure's details and everything. That infrastructure details will be identify the in harness account is the it is there or not. If it is not there, it will delete. And the Docker delegate agent install here, and we are added the IAM role also. The IAM role how it will work, I will explain. See, I will open the README file. Wait, I clearly written somewhere. Yeah, see, on demand true or false. I will explain first code and uh, I will explain the what is the on demand and everything. Okay, first I will explain the code because there is too many confusions is there because if you miss the one point means everything it's very difficult because the Docker delegate agent it's very too complex. Okay, this is a small changes. If you used my exact my names and everything, it will done. First one is identity. I am using the harness harness CICD 0 to 0. I am second one is organizations default GitHub connector and the repository name and AWS account ID and services and this is the same service one I created. If you created the same means you don't need to change anything. The environment and used to do Docker. In this episode, I created this one. And prerequisites, these all things I already explained in the starting. Now I will explain the code. Okay, pipeline. Wait, go to the pipeline, create a pipeline. R- Sorry, import the pipeline. Repository, connectors. Okay, it automatically fetch and everything. Masters. It's just loading. Okay. Import. Just open the pipeline. Total stages, build and push, and deployment. This everything on the commands. And this is the rollback. Now I will explain. Open the code. Okay, this is my pipeline. My pipeline name is episode 6 healthcare Docker CD. Episode 6 Docker healthcare CD. Same name. These are it, and this is my project ID, and this is my organization ID, and the tags, and this is the CI level, and I connected the GitHub, and this is my repository. And if you fork my repository, no need to change. I'm telling in episode 1 onwards. Okay, and total first stage build and push to the ECR and AWS. We are using the CI. This is the first stage. Okay, I'm using the type is CI. Remember, type is CI. OS is Linux. ARM is AMD 64. Type is harness cloud. CI harness cloud. Okay. Now first install the dependencies. It will go to the episode 6 slash healthcare project, and it will run the Python dependencies. And second, unit testing and Python. There's a test app .py file is there. It will unit testing. It will run. Everything is passed, and it will go here. And coming to here, it will create one repository. The healthcare website. This is the repository name. It will create using the AWS secret key and access key. In the production, we are not using the AWS secret key and access key. I already told. Um, the repository name we will create through the Terraform. But I added the step here. And now build the images. It will use the AWS region account ID and the image name. This is the image name. Using the image name, it will build the images. It will build the image, and it will push to the AWS ECR through the OpenID Connect. See the OpenID Connect. This is account AWS account. If you changed your OpenID Connect, this is the my AWS account. This is the my OpenID Connect name. If you change your OpenID Connect means you need to change here. Otherwise, no need to change anything here. Okay, and now go to the pipeline. See dependencies, unit testing, create the repository, and push to the ECR. And next, it will done. It will go to the deployment stage. Okay, second here. The infrastructures we created. We are using here type is SSH. Using the SSH commands only. Through the SSH means we already added the key pair, right? Using the key pair, it will connect it and it will be run the commands. First one is the service, healthcare, and environment deployment and infrastructure. That is Docker EC2. Okay, in this Docker EC2 instance, here only the Docker delegate agent it is executing and everything. The same things we already created and the same name only I added. In this Docker delegate agent only, whatever I AWS EC2 instance I created in that EC2 instance, whatever I install the delegate agent in the delegate agent EC2 instance only, I added the EC2 Docker. Okay, still now it's clear. Now type is commands. Deployment type is SSH and deployment execution steps is commands. First one is deploying the container. It will deploy it. First, it will log in our AWS ECR repository and it will pull that image and it will deploy the application. First, it will pull the image, whatever the image is created, and the latest image, it will pull that latest image. And after pulling, this deployment is the blue-green deployment application. Now, here you need to understood. First, it's a blue-green deployment. Uh, Remember this example, V1, the users will be accessing. Okay. Now, this entire pipeline, suppose V2. Okay. We are deploying the V2. First, we are create two different environments. One environment in the same EC2 instance only, two different environments. This is the V1, it is running. the users will be accessing. And second environment, we are creating the environment. In that environment, the V2 we are installing. First, that environment name is healthcare new. Healthcare new. The V1 application, it is running on port number 5000, and V2 version, it is a temporary purpose only. And this blue green deployment, the green is a temporary purpose, and the old version is still it is running, and new version I am choosing the healthcare new. If it is this name is already exist, it will remove that image and it will build that image with the port number 5001. Okay, and next it will sleep that up sleep the container with 15 seconds, and it will execute the health checks in version 2. This version 2 we deployed with port number 5001, and it's running, and we will check the health checks. If it is passed, the application, if it is passed and health case is passed and the application is success, there's no issues and health case is passed, and at that time only it will be swap the V1. First, if it is passed, status is 200, at that time. Docker old application. This is the Docker healthcare website. This is the, it will stop the application and it will remove the application. And second, the new application also it will stop, and the new application it will remove. It means version 1 it will stop, version 1 it will remove the container, and version 2 container will stop, and version 2 container it will remove, and immediately it will create the green application. It means blue is running and green is deployed, and green is health checks is passed. At that time, blue and green both will be deleted, and again green will be run. At that time, the downtime is 2 seconds. 2 seconds the downtime. This entire process, the downtime is 2 seconds. Wait, I will remove these comments. Okay, this entire process downtime is 2 seconds because the new application is deleting, old application deleting, and new application is creating. At the time, downtime is 2 seconds. If suppose it is failed, new application health checks is failed, automatically it will not execute this one. It will go to the else state. This health state, wait, uh, this is confusing. Okay, automatically it will not go to this one. It will else stage. This health stage automatically the new application, whatever the healthcare application is deployed, and it will stop and it will remove and it will exit. At that time, zero downtime because the new application, the old application, V1 application, it is still it is running, and new application it is created here. See, there's a two ways. Understood carefully. I'm explaining at the starting onwards. V2 application I'm deploying. V1 is still it is running. First, it will remove the if the same name it is there means it will remove that one, and it will create the new application. And this is the version 2. If health case is passed, delete the both version 1 and version 2, and it will execute the second version with the same port number 5000. If it is failed, it will go to the else state, and here whatever the creator the new application, it will delete it. At that time, old still it is running. There is a zero downtime. See, if new application is bad, it will remove it, and old still it is running, zero downtime. If new application is passed and remove the old one, at that time 2 to 5 seconds it will delay, maximum 2 seconds it will be delay, because the new application is deleting and the old application is deleting and directly it executed. This is the swapping purpose and this is the rolling update. Same one container it will delete and new container, same like that only. It is the rolling update and this is a blue green deployment and the 2 seconds delay is there. But we can overcome also this issue. This is overcome. See, first we need to install Nginx on our EC2 instance and that it will be execute on port number 80. The listener port number is 80. And next we will install the Nginx container and we have to add this pipeline. First one is it will deploy the new application, sleep with 15 seconds, and run the health checks. It will health checks is passed, and old container will be stopped, and old container will removed, and new container it will removed, and uh, new container it will removed, and new container it will stop. Here old container it will stop and removed, but the switching time it automatically switch, because here it will replacing the services here. See, directly here replacing the port numbers only, 5000 to 5001. It's directly it's replacing here. It means now we deployed the application 5000, it's just replacing here. Okay, and this is a zero downtime. We are able to access the application without the port number directly with EC2 instance IP only. We will able to access. This is the zero downtime, but I am not using these steps here. If you want to add means directly you can add it here. Just replace here. Just remove this blue green step. Add it there. Okay, just simple. It will first start the new application with a 5001. If health checks passed, upstreamed with 5001 and Nginx reload and stop the old containers 5000. It means it just replacing the 5001 only, like that. And now you understood the blue green deployment. Now we'll check the health checks. We deployed the version 2 and version 2 health checks is passed and everything is passed and it is running. After running and everything, again it will check the health checks if everything is good, and it will come here and here deployment info and the total API backend API versions, backend is working or not, and health checks front end application UI, uh, IP link, and main IP links. The deployment IP links it will give, you will able to access. These all IP links here it will test it, and if it is passed, and this is execute. If suppose, if suppose in this stage or in this stage or in this stage, if it is fail or in this stage, if any stage, if it is fail, automatically roll back. See, the rollback strategies I given here. See, in requirement file, if any using the requirement file, if it is failed, it means in the step 2 or installing the dependency at that time, it is failed. The pipeline will be stopped. And here the app also it means in the first stage, anything is failed, automatically the entire pipeline will be failed. When the deployment the stage, if anything is failed, automatically roll back. The rollback will be enable only the deployment step only, and not build and stage. If application is built and pushed to the ECR, at that time, if any issues will become the deployment, at that time only the rollback will become. The same thing here I'm telling. If any test file is failed, the pipeline will not execute and everything. And if build is success and stage 2 only failed means automatically rollback. I will explain. I will show you the practically how the rollbacking and everything it is work. And now blue green is done. Now I will be explain the one command. Wait, I will show you this one. Where is this one? Okay, yeah, this one rollback. Okay, first it will stop the application. Like whatever the failed the stop one, it will stop the immediately deployment, and it will restore the latest bill, and it will start the previous version application, and it will previous application is deployed, and if health checks means everything it will check. And this is just for 2 seconds downtime only. And if any error in the deployment, if any error in the deployment at the stage, it automatically it will roll back. And yeah, this one only I forgot to explain this step. This is the if version 1 is success, and that image is built and pushed to the ECR, and that is the V1 version, and the application is work success and everything. If it is success, it will add V1 with a tag name is stable. And second pipeline, suppose V1 we deployed executing everything, that application is stable. It will add the pipeline name is stable. If it is added the stable and second we deployed the second version, suddenly it is failed, automatically it will roll back to the previous version, the stable version. Suppose second one is passed, the stable name it will come to the version 2 here. And third one is passed, and the stable image ID tag will come to here. Fourth one also is passed, and the stable name will come to here. And fifth one is pipeline is failed, automatically roll back to the fourth version. And sixth pipeline also it's failed, automatically it will roll back to the fourth version. It will not go to the fifth version because the stable image is on version 4. And sixth version, seventh pipeline is passed, and this table name will be come to the this seventh image name. I will show you these all things. I will build multiple images and I will explain it. Okay, and next is one thing I missed explain. Docker, yeah, on demand. Where is this line? Yeah, on demand true. Actually, we want to use the Docker delegate agent, and the Docker delegate agent it's on demand is false. And I will explain what is the difference between on demand true and on demand false. See, this is the on demand true and on demand false. Okay, okay. See, on demand true, on demand false. See, if on demand true means inside the delegate agent only, we are executing the script. If on demand false means using the SSH support, we are executing the commands on the Docker delegate agent and EC2 instance. Now it is false, and we are not executing the script directly in the Docker delegate agent. With the help of the SSH keys, we are executing the commands. It means we install the Docker delegate agent in EC2, but we are unable to run the script directly. The pipeline, the harness pipeline directly will not execute the commands in the Docker delegate agent. With the help of SSH only, it will execute. Okay, that's why on demand false. And next, has Docker will run on AWS. See, here we are using the Kubernetes delegate agent, and we are using the Docker delegate agent, and we didn't add any network host and everything. We just install the Docker delegate agent, and we install the infrastructure on AWS is a AWS CLI. Using the AWS CLI only, the AWS commands will be execute on the AWS. It means it will build the image and it will push the images. But it will whenever it pulling the images at that time, the AWS command it will work and it will execute. Means at the time we need to install the AWS CLI. That's why AWS CLI we are installing the as an EC2 host everywhere. And one more thing, the EC2 IP also the whatever the detail. See, the Docker delegate has a entire infrastructure, the harness entire platform infrastructure. Everything details has a Docker delegate agent. But in this harness platform also, We added the VPC and AWS account and tag name and key pair, and we tested. These all things we added because of why we added is on delegate is false. And one more thing, this is everything, it will run on the shell script. And if you use the Docker delegate agent, we need to run as a commands, or if you use the Docker Kubernetes delegate agent, at that time it automatically falls. There's a two pipelines we are executing today. One is on delegate is false, that is healthcare platform, and second one is on delegate true. See, you never uh, execute the on delegate true is a Docker delegate agent, because the Docker delegate agent, if you want to deploy the application, means you need to off the on demand. You need to run the commands using the SSH. Otherwise, it will not deploy the application on the Docker delegate agent. But coming to the Kubernetes delegate agent, at the time we are using the Kubernetes commands. I will explain some few examples. Suppose harness cloud, we run the pipeline and it will task. It will send to the AWS account, right? Instead of, see, it will not send directly the Docker delegate agent, and the Docker delegate agent, it will not execute this script also itself. Instead of, we are sending the SSH. The SSH has target host using the SSH credentials. Using these credentials, it will take off the Docker delegate agent, it will execute everything, and we need to install the Docker, and we need to install the AWS CLI, and we need to run that Docker is running or not, we need to check, and we need to stop and run application these times. And see here, one more thing, the harness, the task, and it automatically, the task, it will not send directly, and it will not execute directly to the Docker delegate agent. Instead of, it will send to the SSH key. The SSH key it will run. If coming to the on demand, sorry, on delegate true. If on delegate true means we are using the GoCart e-commerce applications, this harness cloud send the task directly Kubernetes delegate agent, and it will execute these commands inside our EKS clusters directly. That delegates run the script inside our own own infrastructure containers, and it will just harness. You have to install just kubectl commands. It will execute the kubectl commands. But here the shell script, but here the kubectl commands. Okay, this is the commands and this is the kubectl commands. It will directly the Kubernetes delegate agent only inside the container only it will execute. But here using the help of SSH only it will execute. I hope you clear now. Now we will be run the pipeline. Run the pipeline. Okay, it's build and push images. And if you open the console view, you'll able to see here console views and everything. Or if you want to see here directly, you'll able to see here. And any topics I missed in the, okay, the traffic lights. Okay, this is the one concept is missing. Okay, once this CA level is done, I will explain the traffic lights. This is also one of the important concepts. I will explain now. There's a two concepts is pending. The traffic light and how rollback will be work in healthcare platform. If this two is done, the first topic it will be done. Usually this it will be take a few minutes time. Okay. The OS is Linux, ARM is AMD 64. Okay, hardware, everything is connected. And okay, done. Now the code base. Now we will see the code first. Healthcare. This is the backend, very small code. This is the backend APIs, Docker, Doctor. and services. Total 2. The entire code on HTML, CSS, and JavaScript. And this is the just a test script, health and doctors and services. Just health scripts, just a basic code only. Okay, now see it's clone the image, it's clone the repository, and it's a master, and must install the dependencies. It's install the all dependencies. Unit testing. If unit testing all passed, test passed, and health passed, doctors passed, and services passed, and it's created one repository. This is the repository, and this is the mutable, and it's push that image to the E- ECR. And now if I go to the ECR, you'll able to see the stable. Open the new tab. Okay, it is yeah. Now, see healthcare platform, and this is the latest. Once everything is done, at the time it will came to the stable. This is the version one, and see these all are commands. Okay, now it's deployed entire application. You'll able to access the application also, no? And now it is connected the services. The service name is healthcare. It is connected the services and infrastructure, and it is connected the AWS account and AWS, and it's success, and it is connected the deployment and pre-production. It is connected, and the second is the traffic lights, red and blue. Open the deployment file. Okay, go to the readme file. Okay, see, just it is simple. The traffic lights means if you're running the one deployment file, if until if the deployment it is success or failed, and if you run the second, it is simultaneously both pipelines it is running at the same time, means the second pipeline will be blocked immediately, and once the pipeline will be successful at that time only second one will be execute. This is the allow the simultaneously. If you and this is without simultaneously this one, and with the simultaneously means the both applications will be executed at the same time, but we will not allow the both simultaneously, because we executed the both project both pipelines at the same time only, at the time it isolated and it will be stuck, it will be a problem for the production. That's why we are using the traffic lights, and we can use the traffic lights it's multiple ways as also. In the single EC2 instance, or we can our single Kubernetes cluster we can use at uh, traffic lights with allow without allowing the simultaneously. If we allow the simultaneously means we need to create 2 3 EC2 instance. At that time we can create, we deploy the application, same application we can deploy one EC2 instance, same application we deploy another EC2 instance using the simultaneously the traffic lights. This is the way, and we deployed the application, and see it's installing and deploy the application, and it will check the health checks. If health checks is done, uh, this is the stable. Now, if you go and refresh, see it is a stable. Before is a version one v1. The entire application is success. That's why it is became a stable. Now, if you see deployment is done, healthcare is done, and this is the deployment info. And after that, everything is done only. The stable image it will be updated to the ECR. Okay, and okay now it's the time available to access the application. Just this is the healthcare application. Okay, now I will do some small modifications and I will be fail the pipeline. Okay, now I will go to the app file, edit, Okay, my port number is 5000, but I am allowing the port number 5000 to 3000. At that time, immediately it will be fail the code because it unable to fetch if port number 3000, right? The code is entirely 5000. At the time, it will not able to deploy the application. At that time, immediately the pipeline will be failed. Automatically, it will roll back. See, now I'm executing same. Go back, go to the pipelines, refresh, and see. I will run this one. Just 2 seconds only downtime. The pipeline is executing, and, and the application also you'll be able to see. Just refresh, application is done. See, and now it will install everything and it will build the images. See, the building the images. See, the code is I allowed the port number is 3000, but the Docker image is exposed port number is 5000. There's a mismatch is there, automatically build the images. But whenever the pipeline is executing and whenever the health checks at that time, the application will be deployed properly. And the health checks at the time only, it will be failed and it will not deployed and it will roll back it. Okay. Okay. See, done. Clone the repository, install dependencies, unit testing, and create the repository, and it will stable. And coming to here, deployment, it will be fetch the services and infrastructure. It will fetch and it will deploy the resource, and it will allow only one time only and one pipeline at one deployment, one applications. And see here, deployment is started. Now, if you read carefully the logs, this is the deployment. See, it pulled that images. See, it successfully pulled that image and it started the deployment. It will deploy the application, but health checks at the time only. The port number it will redirect to 3000, but we allow the exposed port number is 5000. At that time, automatically the application will fail and the health checks is failed. See, it is failed. And now see, it stopped the failed the deployment. It means it will stop this one. Automatically, it will stop this one and the application is still it is running. Just 2 seconds of delay. See, just 2 seconds downtime and the rollback is done. Just refresh. Application is running. Just for only 2 seconds only delay. If you don't want this 2 seconds delay also, the one thing is you need to install the Nginx and you allow the port number is 80, and at the time you will be able to access the only IP without port number. At the time you will be able to see the application everything and see the pipeline is failed. See, rollback is done everything, and now see the logs, console logs. See, deployment. See, deployment is failed and new version is failed and old version is still it is running. And see, its previous deployment, it automatically roll back in previous version. And now if you open the ICR, refresh, see, it is a stable. First version is stable and second version is latest, but it is not stable because it is failed. And now I will be run one more time. I will change this pipeline. Uh, uh, Okay, and now I allow the 5000 port number. I'm save and execute, and I will rerun this pipeline again. Okay, go to the pipelines, run, run the pipeline, master, and run the pipeline. Now the pipeline will execute properly. It will execute, and at the time you will able to see the version 3, the stable, and see this entire application is just for 2 seconds delay only. And if you want means you can use the Nginx. See it installing the latest image. And if you open that executions, see this is the previous builds. If you open the previous builds, see only the downtime here only. in this step only the downtime. Once this step is passed, and there is no downtime. And now go to the pipelines. Okay, go to the services and these healthcares. And here there's a total two bills. And here you will able to select how many running is everything and timestamp. If you select an environment deployment, if you select means how many deployments is it, you can create multiple deployments, and you can use the multiple deployments, you can create multiple deployment, dev environment, testing environment, production environment. At that time see, dev environment is 1:2, production environment 1:2, and testing is 1:2. At that time you will able to allow the traffic lights. At that time if you allowed, uh, at the time it will deploy the different EC2 instance. It will deploy the different platforms. It will deploy. You need to select production or testing at that time. If you run also the three pipelines, if you run at the same time also, right, it will execute these pipelines on different servers, not in the same server. At the time it will helpful for the traffic lights. At the time green it is good. Now coming to the environment, this environment total two environments, and this healthcare EC2 Docker is success, and it is a artifact. And now go to the executions. Okay, build and then okay, services is done, infrastructure is active, and resources and deployment. See, application is still running. So application is still running. This step has no problem. The previous build is success. Like previous build is failed, but it will roll back on the first version. And now the first version is stable, and this version is failed. Second version is failed, and this is the third version is passed, and the second version it's taken the version one up, it's rollback. And this is the, at the time there is a no downtime. So if you refreshed, there is a no downtime, because it will create the image and it will update the images. It just nothing. See, still you will able to access, will able to access. Okay, my EC2 is okay, no problem. Deployment is success, the health checks is passed. Okay, deployment is done. Its entire deployment process is taken 3 minutes 41 seconds. Now I will go back. This is the way. And now if go back to the ECR repository, refresh. See, first previously the stable image is version 1. Now the stable image is version 3. And version 2, version 3 is normal. And now if the fourth version also it's failed means automatically it will take the stable 3 version. Okay, this is the Docker delegate agent deployment process. I hope you understood this task one project. Okay, but you need to practice. These are too complex project. You need to understood. That's why I explained very detailedly with very slowly I explained. Okay, and the task one is completely it is done. Now we will go for the task two. Okay, and this task two, we are deploying the application on the Kubernetes. And before deploying the Kubernetes application, we need to create the Kubernetes cluster. Okay, that's why first I will explain the Kubernetes cluster. This is the Terraform code for the Kubernetes cluster. And this the first I'm creating the Bastion server. I'm creating the IAM role for the administration access. And I'm attaching the role and security groups. I'm allowing the full security groups, and this is the Bastion server I'm creating. And this Bastion server, it running volume is 30, and it is GP3, and there is a no secret key, no key pair, and it is executing the Bastion server. This is the Bastion server. In this Bastion server only, I will able to access the my Kubernetes cluster auto mode. And suppose this is the VPC. I'm creating one VPC network group public subnets for the load balancer to access the application. And see this entire code for the Terraform code from creating the EKS cluster. If you watching my videos at couple of days back onwards means you will already know this code because if you watched my DevSecOps series means I already explained this entire code. You just skip this code and you can just create the infrastructure Kubernetes cluster and you can if you didn't know means you just understood these concepts. Okay, and public subnets and see my previous my all projects. I if you watched the my DevSecOps 0 to Hero series and there is a project is there. Okay, I will show you here. I see if you watch this project and if you deploy this project, you don't need to listen this one directly. You can create the Kubernetes cluster because the same code, whatever I created the EKS cluster Auto Mode code, it's the same code only. I'm using this here because I just changed the names only. Okay, private subnets and public subnets and NAT gateway and root tables I'm creating. And next, and this the variable. Okay, I am enter infrastructure. I'm creating the US East 1 region, and this is the my cluster name. My cluster version is 1.31. This is the CADR, and these are my Bastion server instance type is T2 large, and this is the Bastion server key name, and this is the GitHub Actions IAM role. I'm not allowing right now. Okay, and next, and I'm installing some tools. I'm accessing the my Bastion server using the SSH agent. I'm installing the Docker. I'm installing the kubectl. I'm installing the ekctl, Helm, I'm, and I'm installing the Elasticsearch. And the it means I'm installing that Sonar Cube. Okay, the Sonar Cube accessing the port number 9000. And today's video we are not able to not using the Sonar Cube, but in future purpose I already installing the Sonar Cube and Helm. Today we are using the Helm. And next, anything provider block. The GitHub Actions, the backup state file it is storing on the S3 bucket. Okay, and now next the setup. Okay, first we need to create OpenID Connect. Okay, just I will show you. I already created. I will just show you the how to create the OpenID Connect. If you watched my this video, you'll able to understand detailedly because I'm just recapping this how to create the infrastructure. But if you didn't understood means, please go and watch this full stack project. Or if you go back to the my Kubernetes series. In this Kubernetes series, if you watched this video, EKS Terraform in the production setup. If you watched this video also, no problem. In this video, whatever I am explaining in the today's video, the same thing I am explaining there. Okay. Okay. I'm just closing this one. Okay. First, I'm deleting everything. Uh, the project is done, right? And I'm okay. Okay. Wait. One small thing I forgot to explain. Okay. We can import we can delete this entirely using that pipeline also. Instead of deleting everything manually, we can delete the ECR repository through the pipeline also. Sorry, it's my mistake. Just go for the harness, clear, copy the path, just run, import, just run this pipeline. It automatically delete everything. And you need to delete manually from the Docker delegate agent. And some services, everything you need to delete manually. See, it is connected to the services, it connected the infrastructure, it will execute at the time, it will delete it started delete it first, it will stop the container and it will remove the container, it will delete that container. See, and the application is stopped. The application is stopped. I'm closing. First you need to clear the infrastructure because the bill will be it will cost because I'm using the T2 medium, right? Okay, I think the video will make very lengthy. If I delete it here means I will directly delete easily. Okay, Yeah, it's done. Okay. Now go back. I'm deleting the pipelines because this project is done, right. If you I keep here means maybe you will get confusion when the uh, when second pipeline is executing at the time. Okay, and I'm deleting the services also. Deleting the services. Okay, first I need to delete the environment. Delete it. Okay, now it's done. Now go back to the IEM role. In IEM role, just go for OpenID Connect. Here I already created OpenID token. Just add a provider, OpenID Connect, and just add the token. The token I given here. This is the token, and add attendance and add a provider block. It automatically create one provider block here. And next go to the IEM roles. I already created one IEM role. This is my IEM role, harness CI CD 0 to hero. Okay, this one. Just add the policies and just nothing. Just I'll show you here. First, go to the policies and trusted policies. You just added this one. Okay, I already given all steps. You can just follow the steps and create one S3 bucket. And in the GitHub secrets and variables, go to the settings. In the secrets and variables, you need to add the region and IAM role ANR. You will get the ANR. You can copy that ANR and create an S3 bucket, and you can copy that S3 bucket, add it. Okay, and I'm fast forwarding this all steps because I already explained multiple times. That's why if you don't know means please watch this video, or if you watch this project, my recommendation, watch this project, DevSecOps project, DevSecOps, full DevSecOps project. Okay, okay, this is the infrastructure pipeline. We need to run manually, or if you uh, PR is merged, automatically triggered, and it will deploy the application. It will deploy the entire infrastructure and everything. See, if PR automatically run means it will be Terraform setup and configured and Terraform format and init and valid and plan. It will not apply. Okay, and manually means it will Terraform setup. AWS it will use the OpenID connect and it will validate and in Terraform init validate plan apply, and it will final summary. Okay, if you want destroy means you need to select the destroy, and it automatically destroy everything. You don't need to delete every infrastructure and application and everything. Just single click it will delete everything. Okay, now I'm creating the infrastructure first. Go here, view run. It will take this entire infrastructure. It will be creating on uh, 10 minutes to 15 minutes time. Okay, EKS run workflow. Sorry, run workflow. Apply, type no, run. It will create entire infrastructure in 12 to 15 minutes. Okay, before I need to delete this. Okay, this repository is already is deleted. See, repository already deleted. Okay, now I need to delete the Docker delegate agent also. If you not deleted also, no problem. If we just refresh, it's automatically disconnected also. Delete this EC2 instance, otherwise the bill will be caused. This video will be lengthy video because I'm explaining the two production grade application projects. That's why this video it will be too lengthy. Okay. Now it's not connected, and now you can easily delete it also. Delegate agents. delete it. Okay, we need to wait for few seconds. Once infrastructure is created only, we need to create the Docker delegate agent. Until unless we don't do anything. Okay, until unless I will explain the code. Okay, go to the episode 6, go code. Okay, this is the harness code. First, I will explain the code, and after that, I will explain the pipeline. Go to the EKS Kubernetes. Okay, and first, I will go to the namespaces. I'm creating the GoCart namespace. GoCart, and this environment is a production and managed by harness. And this is the episode 6. I added some randomly here. Okay, namespace, and I'm creating the services. These services is the load balancers and the internet facing. And this is the public IP internet facing, and we can access this load balancer is the outside the Kubernetes cluster or AWS. Outside the AWS you can access. Okay, like in browser you can access. Type is load balancers and port number is 80. Target port is 3000. This entire application is running on port number 3000. Okay, and now secrets. Okay, this Postgres user is GoCart, and Postgres password is GoCart123, and Postgres DB is GoCart, and this is the URLs, post database URL, this one, and direct URL. This data two URL. This is the database URL, and this is the direct URL, and this is the section secret. It means uh, we can I the section secret key is I directly it given. Usually the section secret key is uh, and we can you want different names, but I given the direct name just for a practice purpose only that this project, that's why I given. uh, and now next, this is the storage class. This storage class is gp3. Okay, and this auto ebs it will create one storage uh, class, and that is gp3. In the volume it will create using that volume. This is the postgres. This is the persistent volume, and this is the postgres pvc and gocart. The label is Postgres, and the storage is 1 GB. And it will use the storage class is auto EBS SC, and this is the deployment Postgres. Name is Postgres, and I'm using a Postgres 16th version image, and it will use that GoCart secrets. This is the secret where name. See if you go back, and this is the secrets. Secret name is GoCart secret. Okay, and it use a postgres username, password, and db username and everything. And the memory is 128 MB and cpu is 100, and limit is 256 MB and cpu is 250. And volume mount, and these are thing command small things. And postgres internet cluster ip, I'm is everything is services. The service is cluster ip I'm using. The port number is 5432. It's tcp. And next, config map. This is the config map. These are few details. Is the next public IP currency symbol is slash. It's a currency symbol. It's a slash, and it is temporarily disabled at 1 minute. And logo level is info, and port number is 3000, and version is 1.0.0, and app name is GoCart e-commerce, and environment is production, and label is GoCart, and it is a harness.io slash skipper, version is true, and this GoCart, remember this name GoCart configure. Okay, and now this is the value.file. See, if you building the images, and every time if you want to get the latest image to update the Docker deployment file, means using this file only it will be created. See, artifact image. In this image, the harness cloud artifact it will build the images and it will be pushed to the ECR. This values.yaml file, it will be pull that image, and it will pull this image and it will execute and it will update this latest image to the deployment YAML file. See, this is the image artifact image. It will execute this command. Okay, this is the deployment file. This is the not a blue green deployment. This is the only rollout deployment strategies, and this is the zero deployment, zero downtime. Okay, and this is the rolling status healthy under deployment. See, first one is app version is v1, kind is deployment, metadata GoCart, namespace is GoCart, label is GoCart, and total two replicas. And now the deployment strategies is type is rolling update, and the rolling update maximum one. It means it will create one, and it everything is good and it will delete one. And now maximum unavailable. It is zero. You need to understood this concept now. See, the rolling update, it will replace, suppose, new pod and old pod. See, rolling update, it will replace old pod with new pod. And the new pod, it is running as a container. It is running as a container, but this application is running. See, the container is running, and it after some time it's crashed or health checks is failed. At that time, the Kubernetes, it automatically uh, roll back the new versions. I will tell you the exactly how it will work. Means this is the first pod, and this is the second pod, and this is the version 2 first pod. The users will be accessing these two pods, and the version 2 will be deployed, and this version 1 and version 2, it's serving the request, and this version 2 is deployed and it is running as a pod, and first pod and second one third pod, and new pod is created, and readiness, the readiness proxy, it will know the whatever it is created the new pod, it will uh, first it will check the health checks, and it will executing or not, everything it will check, and the old pod, it will be keep serving the traffic only, it will not delete the old pod. New pod is running and old pod is running, and new, when the deployment is suddenly timeout, or when application it is crashed, or whenever its traffic is failed, at the time suddenly it will crash and the traffic will be go like this. It means the old pod will be keep serving the traffic, the deployment timeout harness rollback zero downtime, because the old pod is will still it is running, because means the first pod is running, this is the new version pods, and this is the old version pods. The old version pod one is not, and new version pod it is created one, the old pods it will not delete. Once it will healthy and it will check the pods status and the application everything, how exactly it is working the old pod same like that it is working only, no? After that only it will delete, until unless it will not delete it, and it will not execute this one only. Inside it will execute, it will health checks everything is done only, it will replace and it will execute like that, and that is the maximum unavailable. Okay, and now selector and meta table and app is GoCart, and this is the templates and specifics, and here this is the image. See, values.image means whatever the values.yaml file image is there, means that image, the services, the infrastructure, the both the services infrastructure, it will be fetch that image to the AWS ECR, and that AWS ECR it will automatically fetch that images to the values file, and automatically this value file it will be update that image in this place in Kubernetes cluster and it will deploy the application. Container port number is 3000 here and environments. Configurations, GoCart configurations and services is a GoCart secrets. And this is the request maximum and minimum. Resources memory is 256 MB and CPU is 250. And limit is 512 and CPU is 500. And this is the readiness. If pod is ready and it will receive the traffic and Kubernetes, it will remove the pods from the services, it's failed only. It means if the new pod it is created and readiness, it will check the health checks and everything. And see, the path is slashed, the port number is 3000. If it is fail only, automatically it will roll back to the previous pods. Okay, initially delay is 30 seconds. In this 30 seconds only, the pod will be crashed or pod will not work means it automatically roll back. Okay, and liveness proxy also. It works same like if pod is still is alive, the Kubernetes restart the pod if it is fail. Okay, and wait 1 second. Okay, these are the applications. And now I will explain the infrastructure. The two things, same harness project ID, organizations, GitHub connectors, and project database account, and the service is GoCart and deployment we deleted, and we can recreate also one more time. If you deleted also, you can recreate one more time. If you're using me same one only, you can use this one. And okay, I will recreate this three. I will recreate this one and I will create the GoCart services and infrastructure EKS. Okay, these are our prerequisites. Okay, this is the service identifiers and this is the project name and this is the organization ID. Okay, and coming to the these are my connectors, GitHub connectors and repository connectors. It will and this build the images. We are using the harness type is CI. See here type is CI and here type is deployment. If you open the previous one, previous project, healthcare, harness, Dockers, type is CI and here type is deployment. The two difference. It's not a CI, it's a CI plus CD. Okay. Okay, 1 second, guys. I will open. Okay. And code base true. Platform is OS, Linux, and ARM is AMD64. And runtime is a I'm using the type is harness cloud. Okay, it will install the dependencies, npm install, and it will build that build verifications and create the repository using the AWS secret key and access key. And using the OpenID connect, it will build and it will push to the Docker, ECR repository. And second deployment, it's a continuous deployment in the Kubernetes. Okay, type is deployment. If anything is failed, if anything is failed from the deployment stage, any error stage is rollback. If pipeline, if any step or any stage it is failed in the deployment stage, at the time automatically it will be rollback. Deployment type is Kubernetes. And this is the service. My service name is GoCart. I will create now. Okay, and type is Kubernetes and Artifactory. It's a primary Artifactory is ECR image. Using this name only, it will fetch that image and it will update it. And tag is slash v1 slash v2 slash v3 slash v4. It will come and identify is ECR. You must if you are using the same image, you can use. If you want to change the different names, you need to change here, and you can change the same name in the artifact in the Kubernetes when I'm creating. And the environment is deployment. Okay, and infrastructure EKS K8 delegates, and this is the rolling update. The timeout is 10 seconds. Sorry, timeout is 10 minutes. If still it is in the 10 minutes, if still it is continuously it's running the pipeline means automatically it will be rolling update, or if anything is fail means automatically it will run, and skip the dry run is false. Okay, and now the shell script. See, first here it will deploy the application. It Wait, I will show. Okay, it will deploy the application, and if anything is failed, automatically it will roll back. And here the deployment, whatever the deployment is there, using the load balancer, it will be tested. If everything it is working means, it will pass to the next step. It will pass to the health checks. Health checks also will check if health check else is passed and the HTTP code is 200 means it is good. Otherwise, if it is break means it will stall the rollback. See, if any error, see any error in this deployment stage, it automatically fall back. Yeah, created the cluster. I'll go back summary. The EKS cluster is harness EKS cluster and region US East 1 and Bastion server is IP address and 0 worker nodes, because this is the auto mode, right? And that's why if you deploy the application only, the nodes will be created. Otherwise, the nodes will be not created. So I will connect my Bastion server and I will connect my Kubernetes cluster. Harness EKS Bastion server. I will connect with SSH. Oh, I'll go back to the episode 6. GoCart deployment steps. Yeah, okay. Go to the root user. I'm updating the kubeconfig file and I'm checking the ports and sorry nodes, and there is a no nodes, and I will check the namespaces. Kubectl and ns. See, namespaces is there. Okay, now we will we will install the Kubernetes delegate agent in our Bastion server and we will connect and we will deploy the application. Okay, install the delegate agent Kubernetes. See, we have a different types of installations. Is there? One is Helm charts, one is Terraform, Helm provider, and Kubernetes manifest file. And it's very easily to install means the Terraform Helm providers, because the help providers, if you run the Terraform apply, automatically the services and environments it automatically it will create, because if you add the code means it, or whatever the services you want to create, whatever the environments you want to create, automatically it will create everything at one single click. Everything the process will be going on the GitHub actions only. And but in this project I already told I will be explain the manual steps, and after that, once if you understood and if you know the concepts, and in the episode 10 I will create through the Terraform Helm provider. But in this video I am going with Helm charts, or we can go with Kubernetes manifest file. But here you need to download a file and you can copy that file and you can create one file in the Bastion server and you can paste that entire code and you need to run this file. It's little complex. That's why I'm going to the directly with Helm charts. Okay. I'm removing this name. Okay, my Helm charts name is, you can choose any name, not only this name. Okay, EKS delegate agent. Okay, this is my name, and I'm just copying the helm updated. Okay, sorry. Now I'm installing. Usually this one also it will take 3 minutes time to create the pod and connect to the harness. kubectl get ns. See here the delegate agent one namespace is created. In this namespace the pods are one pod will be created and its high availabilities, and if the full traffics are coming and automatically it will increase the pods. First I will check the nodes. See, the node is started, and before the node is not there. Now its node is started, and now I will run the pods. kubectl get pods sn. Okay, it's running. We need to wait for 3 minutes to connect this delegate agent to the harness account. We'll just verify. It's connected, and we just done. See, we created the Kubernetes delegate agent, and that delegate agent is connected, and the communication is started. Now, delegate agent is created. Now we need to create the connectors. The Kubernetes delegate agent, we need to create one connectors. This connector will communicating with our pipeline to the AWS account. But previously, in Docker delegate agent, we created the IAM role. That IAM role and SSH to communicating delegate agent. But here we need to create one delegate agent with Kubernetes. In this delegate agent, we will create one connectors. That connector will communicating with everything. That is the entire in the step only the Kubernetes delegate agent only. Okay, now we will create some services first. Service. My service name is GoCart. I'll check. Okay, GoCart inline and save. Okay, here I'm choosing the Kubernetes. Here we need to add the manifest files. In GitHub, we have a code, right? This is our code. This is our code, and here in K8, here our manifest file is there. We need to add this manifest file path, and you are choosing a K8 is manifest file, and the code is on GitHub. Choose the connectors, continue. Okay, we can use the manifest file identifier name, but if you given any name also no problem. Okay, I'm giving K8 as manifest file. My code is master branch. Here I need to give the path. Here I will give the values.yaml file path. Just open this file. Just copy. This value.yaml file it will execute and it will fetch that ECR repository latest image and it will update to the deployment file. Okay, and you don't need to do anything here, just leave it as everything as a default and submit. It's done. Now coming to the artifact, add a artifact source, the ECR continue is OpenID because using the OpenID only the we are fetching that ECR repository latest image and identifiers. I'm choosing ECR image. This name must will be same, otherwise it will not identify that your ECR repository. Region is my US East one, and it's optional. And image path is you can give some whatever the image you want to create. You can give that name GoCart. Same image only you are creating through the pipeline. And you can give that name. See here I am creating the GoCart. GoCart. Okay, I am giving the same name. Okay, and I'm choosing the values. The input is input. Okay, and remaining everything as a default and just submit. It is connected. Okay, and you can save. Next, the environments and create a new environment. Mm, Environments is a deployment and pre-production inline save and create the infrastructure. New infrastructure. Here we need to choose the infrastructure name K8S delegates inline. I'm choosing the Kubernetes. Here, direct Kubernetes clusters, connectors. Here we need to create the connectors. New connectors. Here I'm choosing connector name is okay, Kubernetes delegate connectors, K delegates, same and using the credentials with a specific harness delegate and continue. This is my delegate I created in the a few minutes back. I'm choosing the same delegate. It automatically select it and save changes. It's verified and success. And namespaces. My namespace is GoCart. If any details is mismatch, it automatically this pipeline will be not execute. That's why these all details we are giving now. It's manually we are creating, and in future upcoming videos we are using Terraform script, and we will create this entirely. That's why I'm today's video. You have to understood these concepts. That's why I'm given the everything in manual steps. Okay, and just save. And now we will create the pipeline. Import pipeline connectors. GitHub connector. Copy the code. Import. Same here. Installing the dependencies. Build. Create the repositories. ECR repository and build and push. And the second step we are using rolling deployment, verify the deployment and health checks. If anything in out of three it is any one it is failed, automatically the rollback will be triggered. And if you see the services, we are using the K, Kubernetes delegate agent. This is a GoCard and this is the environments. This is the execution steps. Now I'm running. This entirely it will take 2 3 minutes. Exactly how it will build means first it will build and push through the ECR and deploy the application in the Kubernetes cluster through the K8 as rolling deployment. It's a harness natively. It's a default rolling update and it will apply the all manifest files, and if health checks is success and it's good, the application we will be able to access in the load balancer. If health checks is failed, the application we will be automatically roll back. The code based install dependencies and it's creating one repository, build verifying. Can open the console also directly. We can check the console also. It's a code based and install the dependencies, build verifying, and it's created one ECR repository. You just refresh here. See GoCart, just open and wait for a few minutes. It will create the repository. Build and push the repositories. It's building the image, and this is um, three stages of ECR Docker file. If you open the code, it's not multi-stage. It is a three stages of code, and in the this is single stage for the healthcare, and GoCart is three stages. First step is dependencies, and once it will execute these dependencies, the binary it will send to the second stage. It is a build stage. It will build everything, and once it will build the build binary, it will send to the production. And this production, it is a very lightweight we are using, and it will deploy the application on port number 3000, and it will create one user and everything is a it's a production. I'm using the, like if you observed in my all previous videos, we are using the multi-stage docker files, and this is the three stages of docker file. See, it's build and mish. It's how fastly, like with three stages, right? That's why it's came very fastly. It's build and verified. Okay, it's a v1 version. It's already updated. Now I will just refresh. See, latest one v1. Okay, now it's connected the services. It's a GoCart services. It's connected, and now infrastructure. It is connected infrastructure. K it is delegate, and it is a cluster type, and it's success. And namespace is GoCart. And resources, it's same like if you run the two times at the same time means it will be isolated. Maybe it will work, but it will same maybe we'll get some issues. That's why if you use the two Kubernetes clusters or two different applications or two different namespaces you want to deploy the same pipeline means at the time we can use the traffic lights. And this is the rolling. See, it start get fetch that all files on K8 manifest files. This is the identities. It is the code and master branch, and it fetch that all files, manifest files. See, all manifest files it fetched, and next the whatever the code is there, the entire code it is installed in the inside the delegate agent. See, inside the delegate agent, the entire code it is installed, and once it is installed and it's run the dry run, like if any issues is there or any misconfigurations is there or not, it's just dry run. And if it is good, that's why immediately it is going to the preparations, and here it's checked everything and it's applied. It will created everything, it's applied, and coming to waiting for apply. This is the event, its spots or everything is created and successfully everything. And if you go here, you can check also here kubectl get nodes and kubectl get ns. See here, you will see the GoCart, and if you run the kubectl get pods GoCart, see total three pods. One is the two pods for the application and one pod for the Postgres database. And it's verify this is the load balancer. And finally, this is the health checks. See, application is deployed. We can access the application also. And before I see these the applications we can access, but once application is done, it will check the all health checks like back end or whatever the endpoints is there. These endpoints it will check and front end endpoints everything it will check. After that only the pipeline make it is success. Until unless it will be checking the endpoints and everything. This is the end just go code applications. Okay, we can add to the cart, verify the cart, and place the order. This is just a go-card application, and these details it will be stored on the database and shopping, about, and contacts, and the login ID intended. And actually, this code I copied somewhere and I did some small modifications and executed. Okay, health checks it started. See, health checks passed 200 and command is completed and the code is done. Total it took 7 minutes 14 seconds. Okay, now we will use this one, add it, view, and total two products I added. This is the address I added and place the order. Order is placed. Okay, now we have it. The admin dashboard also is there. This is the admin dashboard. These are the stores and these are the approves, and whatever the things it is created, we can approve it directly. These are the coupon codes. Okay, we can store also is there. I think I'll check the path. Go for assets, apps. Okay, this is the stores and this is the stores dashboard. And we can add the products in the main dashboard. The users will be who has been accessing the application. We can add the products. There will be see the products and there will be buy it and manage the products. And here we can delete that products also. And these the orders we order the two orders, right? These two orders it will come. This is very small application which connected to the back end, connected to the database, and some of the details it will store to the database. Some of the details it will not store because I didn't fully implemented this code because it's just for the, how the harness will be working, how to deploy the application to the harness episode. This one it's not the project episode, just for a harness episode. That's why basic things whatever things it is required the same things I added here. Okay, and coming back, I will do some small changes in the code and I will fail the pipeline. And at the time, how it is rollbacking and everything, it will check. See, the rollbacking also, if suppose dependencies fail means the pipeline will be failed. Build verification is failed means the pipeline will fail. Create the repository or build and push it is failed means the entire pipeline only it will fail. And the second stage in second stage, if services fail means automatic rollback, and infrastructure is fail means automatic rollback, and rollback deployment, anything is fail or Kubernetes manifest file, any misconfigurations is there means automatically it will be rollback or any health checks. Suppose in the Docker file you did some wrong mistakes and it's build the images. But at the time the rolling update also it will be take too much of time and it will be timeout. At the time immediately it will be rollback and there is a one case is there. And second case, okay, everything is done, and in the code only you added the wrong port number. And the port number means like it will deploy the application when the application is verifying at the time health checks. At the time it will not able to pass the checks. At the time it will automatically it will be roll back the application. Now I will do some small modifications in the Kubernetes manifest files, and we will execute. Okay, I will do some small modification in the deployment file. I added some dummy code and save and exit. We are just testing the how rollback it is working. Open the pipeline, just save master and run the pipeline. It started executing, and we are not using the caching, right? That's why again this pipeline also it will take 7 minutes time. Okay, and we will check the ports here. Okay, now once the rolling update will come, at the time it will come, and the application is without no downtime, zero downtime. If you open, just refresh, see, this is the application stores about everything the without downtime, installing the dependencies. Okay, this is the Kubernetes delegate agent, how we can use the Kubernetes delegate agent and how we can deploy the applications. Okay, I hope you got the clarity how we can create the Kubernetes delegate agent, how we can create the connectors, and how the connectors will be communicating with the AWS account and our harness pipeline, and how executing the everything. And these are small things, and we can use multiples like here I use the when one here I'm creating, at the time I choose the Kubernetes, right, for the deployment. And we can choose the Lambda, we can choose the Azure, we can choose the GCP, and we can choose multiple things, EKS, ECS, and everything. And next episode 7 I will use ECS forget. Using the forget I will connect it and I will deploy one application. Now in today's video you seen the Docker delegate agent installation and deploy the project with the shell. And here next, and you install a Kubernetes cluster delegate agent. That delegate agent deployment is Kubernetes. You executed everything and it is working. And tomorrow's video we will work on ECS, the forget, and the task, everything. It will work on the forget deployment, and we will deploy one application. We will test it, and we will use the Helm repository. The entire code Helm repository, the Helm charts, how it is updating and everything. We will see on the next video. And next we will see the secret managers and everything. Now everything secrets and variables, everything I connected and directly on the code only. And upcoming videos, the secrets and variables we are storing on AWS ECR, and the ECR automatically fetch the details and it will be storing. Okay, it's building the images. Okay, it's building, and now I will go once readme file. At that last I will explain. It's suppose in the package file, if build file never run, and Docker file if it is bad, if suppose if build fail, it's never run. In Kubernetes manifest file, if we added any invalid code, not only the Kubernetes manifest file, any Kubernetes file, any files, services, secrets, config map, anything, if you added some invalid code, automatically build is passed. This is the first stage, and second stage is the automatic fail. It automatically it will be rolled back. Okay, it's build the images, and now the rollback is started. See, automatically it's rollback, but the application is alive. And see here, see some ML file is mismatching is there. It's telling what is the issue and everything. See in the deployment file some issue is there. You can check the verifications, and the rollback also it automatically it's updated the previous version. If you go back to the ECR, just refresh. Here telling the latest is V2, but we are using the V1 version because in the V1 version is the latest. It's a stable applications, but here we are not able to the stable because v1 application is already there in the Kubernetes cluster, right? If you created the version 3 and that version 3 also it's a fail means it will not go to the v2, it will go to the v1 only because that application is stable, the application users will be accessing, right? That same image only it will be rollback. Okay, now I will be fix that issues and I will be execute one more time the deployment file. Go to the GoCart and deployment. Okay, and save commits. Okay, it's done. Now go back, go to pipelines, go. Now I will run and then I will show you how it is creating the images and how it is deleting the old images and how it is creating the old new images and how it is working the rolling update and everything. Coming back here, and if app runtime is crashed, it's build at success and health case is fail means automatically it will be rolled back. Okay, and this is the concepts, and we will go back. Episode 6 is completed. Now it's episode 7. We will what topics we are covering, we will check. This is the syllabus. Episode 7 topics we are covering the Helm charts, value templates, upgrade and rollback and everything. And here we are covering the blue green deployment. Here we covered in the rolling and blue green, but in blue green we covered on the Kubernetes Docker delegate agent only, but Kubernetes delegate agent we didn't cover the blue green, and we are covering the blue green in Helm and AWS EKS and AWS ECS deployment. Mostly we are deploying the application in AWS ECS deployment with the Helm charts and everything. Okay, and IAM role we already I explained today's episode, and EKS connectors also I explained, and production deployment also I already explained. These EKS concepts, actually that concept is the episode 7, but I explained in the episode 6 only. And episode 7 I will cover these topics and I will cover these topics, and we will deploy the same application only, the GoCart application only we will deploy, otherwise we can choose some different application also. Okay, it's creating the ECR repository, it's already is there, that's why it will immediately execute, and it's build and pushed or everything. Okay, guys, if you have any doubts regarding this episode 6, because this episode 6 is more than 2 hours episode, and we deployed the two projects, and I explained some few concepts, right? That's why it's more than 2 hours video. And in this regarding this 2 hours videos, 2 hours video, if you have any issue, please reach out me in the LinkedIn and connect to me and ask your doubts or comment our the descriptions, uh, charts, and I will reply. Or you can directly, WhatsApp community is there and Telegram community is there. You can join any Telegram channel and you can ping me. Whatever our students or YouTube peoples are there already, and there will be reply your common doubts. If you message me, I will try to reply in 1 hour, or more than is within 1 hour or within one day only I will reply. If you want the fast response means join the Telegram channel, link in the description. And if you message me, if you message in one of our community member will automatically reply if they know the answer. Otherwise, I will be replied. Okay, and it's it's take 5 minutes time. I will show you the after that only I will end this video. Okay, bots are running and It's built. Yeah, build is done. Okay. Okay, service done, infrastructure done, and rolling deployment. Here you need to see how it is deploying the rolling. It is applying the pods. It's a one by one it will apply. See, waiting for the deployment GoCart rolling out to finish one out of two new. Same here. It schedule the one new one, it will delete the new one, old one. And see the this is successfully pull the version 3 image, and this is the version 3 image. See, version 3 is the latest. It's pull the image, and if it is failed means it will go back to the version 1 only. Because the version 1 is the stable. It will go to the version 1. See, the Go code images, it's creating the pods. See, the two pods are running, and one pod is created. It is created, and another one it is terminating. Same. See, it's deployed successfully, and it's connected refused to the uh, 3000 port number, and it started checking and everything. And now go back, kubectl get pods minus n. See, it is the new version is deployed, and it started verification like Postgres is deployed or not. If everything is deployed, now it's done. Verification also, it's everything is done. See, pods are three pods are running. This is the load balancer, and this is the application, and the downtime is zero. Downtime is zero, and it's check the health checks, and health checks is 200 is everything passed and connected. Okay, this is the deployment, and see, this is first deployment. It's take the 5 minutes, 7 minutes. Second deployment is taken the 5 minutes only. Usually, we are not added any caching, right? That's why maybe it's local caching it is using. That's why it's automatically built. Okay, this is the project, and if you want to destroy the entire project, means just go back to the here and EKS, choose destroy, and type S. It took 15 minutes time. It will destroy everything. You don't need to delete anything manually. Okay, and you need to delete manually on the pipeline only, and delete the pipeline. Okay, I'm deleting that delegate agent also. Okay, sorry, once if it is disconnect only, I will able to first I will delete the services and everything. I will be create services on every episode, and I don't want to use the same details in every episode. I will create multiple services, and I will create multiple deployments. I will create that deployment, delete. Okay, the reason was okay. The connector is there. No, once it will done, I will be delete everything. Okay, guys, it will be take for 12 minutes time, and I hope thanks for watching entire content. I hope you guys are like this video.